Now calculate this integral. Integral of x divided by, so suppose it already gave you the denominator in factor form, x minus 2 times x squared plus 1 times x squared plus 4 dx. Okay, very well. First of all, the degree of the denominator is greater than the degree of the numerator. So in step 1, we need to write the denominator in factored form, which is already given to us. We're lucky. The degree of the denominator is larger than the degree of the numerator. Step 1, write the denominator in factor form. We already have it here, so x minus 2, x squared plus 1, x squared plus 4. Okay, step 2. We need to use partial fractions. We're going to copy down whatever our fraction is, x divided by x minus 2, x squared plus 1, quadratic expression, x squared plus 4, another quadratic expression, equals. This is linear. This guy is quadratic. The same for this x squared plus 4, this expression here. So what are we going to do? We're going to create 3 partial fractions. So a over the linear term, x minus 2. Plus, for quadratic expression each, we need to have linear expression as the numerator. So here you have x squared plus 1. On its numerator, you have to have a linear expression, bx plus c. Your last denominator is x squared plus 4. On its numerator, you have to have a linear expression, dx plus e. That's how we break down when we have quadratic expressions on the denominator. We have to have linear expressions on the numerator. Then in step 2, we solve the equation. Okay, let us start. On the left-hand side, we have x. On the right-hand side, we need to create this new numerator. This guy is equal to, the denominator is x minus 2. X squared plus 1, x squared plus 4. This guy is a times x squared plus 1 times x squared plus 4 plus this guy is multiplied by these two, bx plus c times x minus 2 and x squared plus 4 plus, so I'm going to write the rest of it here, dx plus e times x minus 2 times x squared plus 1. I'm going to write down this numerator there. So it is going to be x equals to a times x squared plus 1, x squared plus 4, plus bx plus c, x minus 2, x squared plus 4, and plus dx plus e times x minus 2, x squared plus 1. So let me erase this one. Okay, very good. Now we need to distribute these, multiply, and set it equals to a and solve for all of these variables. Okay. So my x is equal to a times x to the 4th plus 5x squared and plus 4 plus bx plus c, x to the 3rd plus 4x minus 2x squared minus 8 plus dx plus e times, here you get x cubed plus x minus 2x squared minus 2. We need to continue this. X is equal to a x to the 4th plus 5ax squared plus 4a plus, okay, let's just distribute these. bx, distributing this here. Then you need to distribute c as well. So bx to the 4th plus 4bx squared minus 2bx cubed minus 8bx. Now we distribute c, cx cubed, 4cx minus 2cx squared minus 8c. And now we're going to do the same thing for dx and e. So here we have plus dx to the 4th plus dx squared minus 2dx cubed minus 2dx plus ex cubed plus ex minus 2ex squared minus 2e. Okay, very well. So now what are we going to do? We're going to divide this based on the largest exponent of x. I'm looking for all of x to the 4th. So here you have x to the 4th times a plus b plus d. And then we have x to the 3rd. Let's see, what do we have for x to the 3rd? Negative 2b. We have a c, negative 2d, and e. Negative 2b plus c minus 2d plus e. And plus x squared or x squared, let's see. We have 5a, 4b, minus 2c. We have a d and negative 2e. Five a, 4b minus 2c d minus 2e plus x times. Very well, for x, we have negative 8b, 4c minus 2d and e. Finally, the constants 4a minus 8c and minus 2e. This sum is equal to x. So you only have one x. It means that you have x to the 4th times 0, x to the 3rd times 0, x squared times 0, x times 1 plus your constant, which is equal to this sum here. So what's the meaning of that? It means that many of these coefficients, their sum, their combinations are equal to 0. So you can form this guy. A plus B plus D is 0. Negative 2B plus C minus 2D plus E is also 0. Then you have 5A plus 4B minus 2C plus D minus 2E is also 0. This guy is equal to 1. Negative 8B plus 4C minus 2B plus E is 1 because the coefficient of x is just 1 and the constant is also 0. Okay. 4A minus 8C minus 2E is 0. We have a system of 1, 2, 3, 4, 5 equations with 5 variables. With 5 variables. You can start eliminating some of these, do the substitution, and find the missing values. Very well. The last example is, what if we have an integral like this? What is our approach?